calculate the correlation coefficients in table 2. The correlation coefficients in table 2 are the correlation among the latent variables. If you look at your output, if you go to your output, you can see there is a section about the covariance among your latent constructs. And the last columns are the standardized R. These are the correlation coefficients among your latent variables. It is based on the measurement model with all the factor loadings. So this is the correlation based on the latent variables. That is what table 2 is about. For table 3, actually what we do is to take the submitted scale. Find the submitted scale, take the simple average of the items for MD, average for all the items for TD, etc., and find out what is the correlation coefficient. So table 3 are observed scores, table 2 are the latent constructs. That's the question from Sally. And from Mavis, in our example, we fixed the reliability to 0.8. How can I know it is 0.8? Can we fix it at 0.7 or 0.9? Yes, you can fix it at 0.7 or 0.9. Okay, so you need to justify why you put 0.8 or 0.7 or 0.9. If you cannot justify, simply put 0. Now, however, what you can do is to run a sensitivity analysis. That means I don't know what is the reliability for IAPD1, but I suspect that there may be measurement errors. Then you can run your analysis with no measurement errors, so reliability equals to 1, or you substitute 0.9, 0.8, and 0.7 to see if the results are any different. Then you can report in your study saying that, hey, I have tried different reliabilities, 0.7, 0.8, 0.9, and 1. And they all show that the results are all very similar. So this is how we run the sensitivity analysis. For reliability, typically we need at least 3 items to calculate reliability. If you get 2 items, yes, you will still get the reliability, but it is not very reliable. The reliability measure is not very reliable. Xinhua asked about the questions of missing values. In your data file, in the past, in R, you have to put NA in your data file as missing values. But about 2 years ago, they changed it. So now you can just leave it blank, okay? Leave it as space. It will be considered as missing values. You don't need to do anything in measure Q. It will automatically read those missing values. Maxwell asked about an error message. I don't know because I have not experienced that. Okay, now we have 3 more examples today. Slide 179. Okay. This is an example of second-order constructs. So some of you asked about second-order constructs. It is a paper that we are trying to develop a scale. I repeatedly remind you, don't develop your own scale. They developed a scale for measuring HR flexibility, human resources flexibility, HRF. They consider HRF is a second-order factor with 5 dimensions. Resources flexibility in HR practices by 5 items. Resource flexibility in employee skills and behaviors, 4 items. coordination flexibility in HR practices, 4 items, coordination flexibility in contingent worker skills and behaviors, 4 items, and finally, coordination flexibility in employee skills and behaviors, 4 items. So how can we define second order factor in MeasureQ? So the first line is to read the data file. In the model, I have not finished, I have not completed. The first 5 lines are simply the first order factors. For the second order factor, HRF, which is RFHRP plus RFE plus CFHRP plus CFCW plus CFE. So it is simply defining the measurement of the second order factor, but the items are no longer the item is in your data file, but they are constructs. This is how we define second order factors. This is the way to do in the Vern. One reminder, if you have a second order factor, it must be defined at the very last. So you must define all the first order factors before you define any second order factor. Otherwise, you cannot find the dimensions. So I have completed. You need to complete this line on your slides. Now, let's copy and paste this and run it to see the results. You got your output?
Yes.
Oh, great. Seems to me that you have a pretty fast computer. I thought my computer was very fast. So seems that you always is the earliest to get the results again. So anyway, number of requested bootstrap sample equals to 1,000. Number of completed bootstrap sample equals to 1,000, which is good. First, we will look at the fit indices. Chi-square with 184 degrees of freedom equals to 181, which is good. CFI equals to 1. RMS is 0, SRMR 0.041. So the fit indices indicates that our model fits the data well. This is the first thing you need to report. Then we will go to table 2. First, we will look at the reliability, the diagonal elements. There are 2 things that I want to draw your attention. The first one is, do you see there is a second order factor here in table 2? HRF is a second order factor. So this reliability is not complex alpha, it is omega H. Omega H. For the diagonal element, the reliability for the third dimension, CFHRP, has a subscript B, capital letter B next to it. If we go to the note, the third line, B equals to construct reliability significantly lower than 0.8. So here, 0.742, this is significantly lower than 0.8. So we have minor concern about our reliability. But fortunately, it is not an A. An A means that the construct reliability is significantly lower than 0.7. If it is an A, then you cannot continue. But it is a B, then you can continue. You need to put it as a limitation. you need to mention this in the implementation section. If I make myself clear, so we look at the reliability, there is a subscript here which indicates that the construct reliability is significantly lower than 0.8, but it is not significantly lower than 0.7, so it is only a minor concern. The next thing is we will look at the convergence validity. Now you can see that we have more items with subscript C. That means the items have standardized factor loadings lower than 0.7. Well, since they are not lower than 0.5, these are only minor concerns. But if we look at the AVE, this is the problem. For AVE, the third variable, the AVE is 0.421 and it is significantly lower than 0.5. It is a major concern. That means we do not have convergence validity for this dimension, CFHRP. Even worse is the AVE for the second order factor, which is only 0.263. It is significantly lower than 0.5. What that means is the results show that we do not have convergence validity for your second order factor, HRF, and also one of the dimension, CFHRP. So if I am the reviewer, I will reject this paper because they do not establish a good measurement scale when they develop a measurement scale. Okay? If we look at the discriminant validity, we don't see any subscript next to the correlation coefficient, so there's no problem with discriminant validity. But this paper, although the data are simulated, but I try to simulate as close as the original article, and I find that the AVE is very bad. Do you notice that many management studies, actually they do not report AVE. They have not paid enough attention to the convergence validity. If we use the standard about AVE, then this paper cannot get published. Any questions about this example?
Yes.
Yes? What's your question?
Yes, and it seems that the culprit or the troublemaker is a CFHRP. So suppose I were the instructor, I were the original authors. May I just get rid of that construct and then rerun the model and suppose everything works, and then I will, report the second order factor with only 4 underlying dimensions.
CFHRP, right?
Yes, get rid of that.
It's easy. I go back to this slide. I remove CFHRP. And then I remove CFHRP from the second order construct. Okay? So I run the model again. So it is very handy. It is easy. If you have this question, I just run it again without CFHRP.
Yes.
That's what I'm doing. It won't take you too long to find out the answer. I got the answer. Okay?
Oh, still bad.
The fit indices, first we need to look at the fit indices, which are good. So our model fits the data well. Then we look at table 2. Okay. So the omega H is a little bit problem. There are minor concerns in the factor loadings. There are no concerns about the AVE for the dimensions, but the second order factor is problematic, right?
Yes.
So What that means is the authors have developed a scale for the 4 dimensions, not 5, and they fail to create a second order factor.
Mm.
Okay,
Yeah,
good. Now, do you like Measure Q? Because it's so easy to test a different model.
that's great.
Okay, it's so easy to test a different model. I just changed the model and then I got the results. Now,
And then in summary, the Measure Q is for measurement, not for the ACM. Where once we pass through the Measure Q, we still have to actually conduct the traditional ACM in order to test the hypothesis, right?
correct. As I
Okay.
said, in SEM, for any SEM model, we have 2 steps. The first step is to make sure that you have a good measurement model. The second step is to test your hypothesis.
Yep.
Okay, if you test your hypothesis without establishing a good measurement model, then I don't know what you are testing. So if your measures cannot demonstrate convergence validity, discriminant validity, then we don't know what you are testing. You get it? So here, you have a measurement model. Then tomorrow, I'm going to show you how to test with a full model. You just add the path parameters here. You just add your path analysis here in your measurement model. Then you get a full model. Do you get it?
Yes. And please do not save your PowerPoint because this measurement is incomplete because
Okay.
you adapt my question. So thank you.
Now, we have 2 more examples. This example has 2 second order factors. I'm on slide 181. We have 2 second order factors. The first factor, latent variable, is participative leadership, measured by 4 items. And then we have the first second order factor, ethical climate, which has 3 dimensions: CLNG, which is caring, rules, which has 3 items, and then law and cost, which has 2 items. Another second order factor, responsible innovation, has 4 dimensions: anticipation by 3 items, reflexivity by 3 items, inclusion by 3 items, and responsiveness by 3 items. The simulated data set is in a3.csv. Here, let's compare them. Ethical climate, okay, we should have CLNG plus rules plus, oh, capital letter, CLNG plus rules plus LC. So we have 2 second order factors here. Both second order factors should be at the end. Our I is ANTC plus RF LX plus INCL plus RSPN. So I've completed my model. And then we can copy and paste this to R. Oh, something wrong. Ah, okay. Quotation, okay. You can ignore it. Sometimes the PowerPoint quotation, okay, change a little bit, but this is not an error message, okay? Don't worry. Okay, I got the results. You got your results?
Yes.
Okay, although it says that there's an error message, unexpected input in quotation. Do you have this error message?
No.
Sometimes when I copy from my PowerPoint, I have this error message, but it doesn't matter. Okay, so it won't affect your results. Okay, it is just because you copy and paste from the PowerPoint. Number of requests, the bootstrap sample is 1,000. Completed bootstrap sample is 1,000. So today is our lucky day. Fit indices, 360 degrees of freedom, 7 degrees of freedom equals to 399 chi-square. CFI 0.997, RMSE 0.013, and SLMR 0.026. So first, read the fit indices, and it shows that the fit indices indicates our model fits the data well. Second thing is look at table 2, the correlation, the reliability. Here you can see that all the reliability coefficients has no subscript next to it. So all the reliabilities are good, all higher than 0.8. And for the second order factors, ETH and RI, these are omega H. These are omega H. The second thing that we will look at is the convergence validity. If you look at the AVE, these are all good. They are not significantly lower than 0.5. Even though for ETH it is 0.481, there's no subscript next to it. That means it is not significantly lower than 0.5. And there's no subscript in the standardized factor loadings. Okay, so that means these are all not significantly lower than 0.7, which is very good. So we have evidence of convergence validity. Discriminant validity, we will look at the correlation matrix. Oops, do you see there are some subscript C next to the correlation coefficients? Hello? Do you see that?
Yes.
Okay,
Yes.
now let's first look at this part. There's a subscript here, CLNG and rules with LC. These three, CLNG, rules, and LC are actually the dimensions, the 3 dimensions of ETH, right? Hello?
Yes.
Therefore, we don't worry about their discriminant validity because they are the dimensions of a second order factor. If the correlation is too low, you won't get a second order factor. So it is fine, although it shows that they may have minor issues with discriminant validity, but actually they are the dimensions of a second order factor. Similarly, if you look at this, ANTC, RFLX, and inclusion, they have a subscript C. So we have slight discriminant validity issues here, but since they are the dimensions of a second order factor, we don't worry about the discriminant validity here. Have I made myself clear?
Yes.
So although this shows that we have discriminant validity issues, but in fact, they are the dimensions of a second order factor, so we don't really worry because they are like the indicators of the second order factor. We want them to be highly correlated, otherwise they cannot show a second order factor. Okay?
I have a question.
Yes.
A question about table 2, the last note. And then what does that mean? The observed mean of second order factor is based on all items, ignoring the second order structure. What does that mean?
Okay. Again, this is talking about the mean.
Yeah.
How can we calculate the mean of a second order factor? This is the mean of the dimensions. And the mean of the dimensions are the mean of the items. So it is basically the mean of all the items of the dimension that creates the dimensions.
Oh, okay.
So it doesn't have any second order structure for the mean.
Yep.
You get that?
Yes. Thank you.
Good. So today, our last example, my favorite article, Green et al. Okay. That is an example that we will come back when we talk about latent interactions. It is a study about work family conflict. We have 3 items for work family conflict. Work scheduling autonomy. We have 3 items, and this is a moderator. Emotional exhaustion or burnout is our mediator, which is measured by 3 items. Then we have another mediator, engagement, which has 3 dimensions: rigor, dedication, and absorption. So second order factor engagement has 3 dimensions, each dimension with 3 items. We also have supervisor weighted promotability, 3 items. Increase in salary is a single item measure. In fact, this is from company record. Performance evaluation is also a single item factor because it is from company record. So let me show you how to write the measurement model. We read the data file, work family conflict with 3 items, burnout with 3 items, autonomy with 3 items, rigor, dedication, and absorption, each with 3 items. And you will see the second order factor, engage, we put it at the very end. Okay, second order factor needs to be put at the very end. Promotion has 3 items. Salary, single item. Therefore, it is measured by SAL, but the factor loadings equals to 1, and we assume that there is no measurement error. Therefore, we put 0 for the measurement error. Similarly, for performance, we change the single item PERFUV to the latent construct perform. So we have fixed the factor loading to 1 and the measurement error to 0. One more thing is some of the items here are measured by the leader. Some items are measured by the subordinates. Therefore, since each leader may have more than subordinates, therefore it is a nested data, okay? Each supervisor rated more than 1 subordinate. So we have to control for the nested data. We can add a command here. Cluster equals to your grouping variable or the cluster variable called leader. So I have an ID for the leader, and each leader may have more than 1 subordinate, 1 record. We will come back to this when in our last day, when we talk about multi-level models. When we talk about multi-level models, we will come back to the cluster variable. Now I copy and paste this and run this in R. Yeah, my R today doesn't like my quotation, but it's not actually an error message. It still run. Oh, this is a fast computer. You got your outputs?
Yes.
Now, if we go to the top, do you notice that number of requested bootstrap sample is 1,000? Number of completed bootstrap sample is 885. So there are 115 bootstrap samples are removed. They are removed. You can try again with number of bootstrap samples to 2,000 so that you can get more accurate results, but you can stay with that. The reason is not because you have a bad model, but it simply reflects that some of the parameters are very close to the possible limits. First, we will look at the fit indices. We have 208 degrees of freedom. The chi-square is 394. Okay. CFI 0.945, RMSEA 0.068, and SRMR 0.057. So our fit indices indicate our model fits the data adequately. Again, when I said about MLR, do you notice that I read this number? The first column are from maximum likelihood. The second column are from MLR, which handle the normal distribution better. But there are also two sets of CFI and TLI. I only read the first set because the second set, robust CFI and robust TLI, are based on the equation created from Laverne, which doesn't get popularity. Okay, so I won't report this. I will report 0.945. After we look at the have read the fit indices, we'll go to table 2. Oops, why I always hit the wrong button? Table 2 here. First, we will look at the reliability. Oops. I will make it smaller. Okay. So I have the reliability. Most of the reliabilities are good, but for the single item factor, do you notice that salary and performance? Okay, they have a reliability of 1 because we fixed them. We only have one issue of reliability here, is for the absorption. Okay, the second or the first dimension, first order dimension, absorption. It has a construct reliability of 0.734. It has a B here. A B here, if we read the notes, B means that it is significantly lower than 0.8. So there is a minor concern about the reliability for absorption, but that is not a major concern. That is not a major concern. Then we look for convergence validity. For AVE, you can notice that all these AVEs are good. Even for absorption, it is close to 0.5. It is not significantly lower than 0.5. If we go to table 1, you will notice that we have two items which have standardized factor loading significantly lower than 0.7. Fortunately, it is not significantly lower than 0.5. Do you remember I just mentioned that the reliability for absorption is problematic. It is probably due to item Y9. This item, it has very low standardized factor loadings. So if you want, you can remove this item and test it again. So in terms of convergence validity, we have minor concerns because we have two items which have standardized factor loading significantly lower than 0.7. Fortunately, it is not. But these are only minor concerns because they are not significantly lower than 0.5. So really ask the question why the AVE for this is below 0.5. Why we don't have an asterisk? Because for this particular AVE, although it's lower than 0.5, but we create the confidence interval FH variance extracted for absorption here. It is 0.494, but the confidence interval indicates that the upper limit is 0.553, so it is not significantly lower than 0.5. Therefore, you don't see the pound sign. Though it is lower than 0.5, but when we look at the confidence interval, it is not significantly lower than 0.5. Therefore, you do not consider it as a problem. Have I answered your question, Willa? Good. Okay. So where we are at the discriminant validity, we have problems here. For discriminant validity, here you can see that we have subscript C and also a dollar sign. A dollar sign means that the AVE is significantly less than this square correlation. And it's more than the C means that the correlation is significantly larger than 0.7. Now, we have discriminant validity for the 3 dimensions of engagement here. But again, because they are the dimensions of a second order factor, we don't concern about the discriminant validity. If they do not correlate high, you will not get a second order factor. Do you get it? Just like in any of these latent variable, we expect the items to be highly correlated. Otherwise, we cannot form a latent variable. Similarly here, because these three are dimensions, first order dimensions of the second order factor engagement, so we don't worry about their discriminant validity. Good. Any questions?
And suppose we utilize the measure Q in our publication, and how should we cite? Just cite the paper you published 2024?
Yeah.
Would that be good enough? Okay.
Okay. Because that paper explained all the criteria. It explained the expected threshold, and it also include the measure Q. So you can just see that paper. That paper is cited now about 1,000 times every year.
I will cite it soon.
Well, it depends on whether your results are good or bad.
Yeah.
Right? Okay. Now, let me repeat what we have covered today. First, I showed you how to do a measurement model. You can see that it is very simple. It is very easy to create a measurement model. Like here, we define a measurement model with an equal sign and a stick with all the items on the other side. So it is easy to define a measurement model. I also shows you that we should use the MLR estimator, okay, because it handles non-normal distribution better. I also shows you about the paper about how to test reliability, convergence, and discriminant validity. In many of the management papers, they only report the reliability. They didn't report convergence and discriminant validity. And some report discriminant validity by comparing nested models, 5-factor model, 4-factor model, 3-factor model. It is a bad way to test discriminant validity. You can cite my 2024 paper to criticize. So you should ask the authors, if you are a reviewer, you should ask the authors to read my 2024 paper and ask them to use Measure Q to demonstrate the quality of their skills. So you should first demonstrate the reliability. Reliability, you can use Compass Alpha, construct reliability. If your variable is a second order factor, you should use omega h. You should not report Compass Alpha or construct reliability, because construct reliability or Compass Alpha ignore the second order structure. Then for convergence validity, many management papers just say that our model fits the data well. Then they say we have convergence validity. That is wrong. Some says that our factor loadings are significant. Well, everything is significant if you have a large sample size. Some people say that, well, our items, our lowest factor loadings is 0.4, for example. It's not good enough, okay, because you are not explaining the variance of the items. If we adopt the approach by Farnell and Nacker, we expect the average variance extracted to be at least 50%, 0.5. What that means is our latent variable can explain 50% of the variance of the indicators. Finally, we talk about discriminant validity. Okay, so it is not good to say just 5-factor model, 4-factor model, etc. We should test by test all correlation coefficients to see whether they are significantly higher than 0.85. Also, we should compare the square correlation with the AVE to demonstrate discriminant validity. Very few management studies do that. Okay. So I hope that I didn't create any of this. I borrowed all this from marketing, from Farnell and Nacker, and from here et al. So I created the Measure Q software to help you to do all the analysis. So it looks pretty complicated, but if you use Measure Q, you can easily get the tables. You can easily get the tables, and it shows you the tables, actually tells you whether you have passed the reliability test, the convergence validity test, and the discriminant validity test. I hope in the future, management studies and psychology studies can do a better job in demonstrating the quality of the measurement.
Two more questions.
Yes.
First, if I would like to include the control variables, would you include the control variable in the Measure Q, or
Yes.
just leave that alone?
Yes, you include the control variables in the Measure Q.
Okay. And then the second question is, would the Measure Q be able to handle the data that when I don't have the access to the raw data, but when the author report the variance, covariance, and the mean standard deviation of the variable, would I utilize the data set to replicate or recreate the construct validity measures?
The answer is no, because
okay.
Measure Q is based on bootstrapping. Bootstrapping requires raw data. Okay?
Yep. Yes.
So no, the answer is no, you cannot.
Thank you. I really appreciate and enjoy your straightforward answer.
Okay? But actually I can. You cannot, but I can. Because if you give me any correlation matrix and the means and standard deviation, I can create the data set.
Oh, okay.
Anyway, okay. So one more point. Like in one of our example, the last exercise. Okay. Example A4 exercise A4. In our last example, we find that there's one item of absorption is bad. Y9 is bad. Then what can we do? Okay. So I just take away Y9. I run the model again. Got the results, and you will notice that the results is much better now. Okay, now the problem is you have two sets of data. One set you have all the items. The other set you have removed one item. You have removed one item. Typically, in marketing, they allow you to remove items to improve the quality of the model, to improve convergence validity and discriminant validity. That's why marketing used Fontenay-Necker approach in all studies, because you can delete items. However, in management and probably in psychology, you have, if you use established scales, you have to use all the items. If you remove one item, like what I have just done, it depends on whether it is really necessary. If it is really necessary to get good model fit or good quality, then you will say, I remove one item. You try to go to the item and explain why it's not appropriate for your sample. Maybe some items developed in a different country, that item may not be applicable in your sample. You explain it. And also, what you need to do is to report your results with the reduced items in the body of the manuscript, and report the results of all the items in the supplementary file. And then you need to compare the results and tell the editors and the reviewers that the results do not look very different. Your hypothesis, your conclusion about the hypothesis are exactly the same in the two data sets, hopefully. So you will put it in the supplementary file. Do you get my point? In management, we have a more stringent rule in deleting items. You are not allowed to delete items at your own will. But in marketing, you can do this to improve the quality of your scale. So in management, if you do this, you have to report the results, both sets of results, one set in the body of your paper, one set in the supplementary file. If you want to learn how to write this, I think several of my papers in empirical studies published in the past 2-3 years, many of them had to remove one item. You can see how I write those. Okay. That's all the materials I want to cover today. Do you have any questions?
One last thing. Yes, one last
Yes.
thing. We were instructed to download and install MASS, MASS, and we have not utilized that. So we are going to utilize tomorrow or not?
Well, it is incorporated in my programs. Okay.
Oh.
So MASS is used for the MCCI for Monte Carlo simulation. Okay, so you will not use it in these 3 days, but next week you are going to make use of that.
Thank you.
Any
See you
other
next week.
questions? Okay, if not, remember tomorrow, 9 a.m. to 1 p.m. We don't have any lunch break. Okay? So if you have any questions, I'll answer, either send me emails or I will answer at the beginning of tomorrow's session. Okay, good. I'll see you tomorrow. Thank you for coming.